Deployable and transformable structures. I gonna bring today a use case of how we find out the way to leverage the use of parametric and modular design in a medium-sized product that is basically what we are trying to build here in Canada. Initially, I want to give a quick overview of who we are. So we are a group of architects passionate about geometry, parametric design, and sustainability. We have three locations. DSS Studio is the Canadian brand with 2 years. It's kind of a startup, a small business with the mission to bring parametric design to the construction industry. We have SMIA in Spain, dedicated to generate knowledge about the morphology in architecture and how digital design can disrupt the IEC industry. And we have close to here Dinamica, that is our Mexican brand dedicated to text prototypes and aligned with the DSS Studio to make parametric design a common practice. So we are all have a background in architecture, and we just would like to bring all of these concepts to the real life construction day by day. So what we have done, or what we do is we do we have done any kind of project that can help to improve the outcome in terms of sustainability and a good way to the use of the materials. So we are being in temporary structures. We are always looking to have our structure like being habitable. So always there is a human factor that interact with the structures. And how we do that. So basically our core design concept is we develop an algorithm that we can use to create and configure adaptable, deployable structures that have these four factors: scalable, transformable, fractable, and deployable. So if I go in details of any of them, so those are the factor that makes the structure working in the way that we can make a better use of the materials. We can leverage the design for different purposes, and the concept is basically based on two elements. The first one is the scissor that you can see here. We created parameters so we can modify initially as very basic elements, but at the end, as we progress in the presentation, you will see how this become actually a 3D element. So using these basic parameters, we are able to manipulate the geometry, and also we start looking to see more in 3D how we can manipulate the space. And at the end, the goal is to create a shell or create something that is can be used as a cover or as a wall. So we are getting close to the definition of construction elements. Let me see. Oh, yeah. So using those basic elements, and at the end, in a combination with any other parameters, we are able to create these three geometries that are, as you can see, are enclose it with those basic concept that we have before. This is fractal, so we can um, move it, close it, or move it far, and the element will, the behavior of the element is exactly the same. It's transformable totally because it's foldable, so you can have it in one position at one time, and it's another position in another time, and it's completely deployable. So it's a standalone element that can use it for a shelter or an enclosure. The next one. So basically, the parametric design help us to define or control two basic elements that are the geometry and the deformation. So the idea behind of all of this is all of these elements can be transformed or adapted in the design stage, and can be directly linked to the production, either if the production is going to be on site or the production is going to be on a fabric, right? And one of the ideas that we try to bring with this kind of design is working on site or working with the raw material create a lot of waste, and we can reduce that waste, and we can create a better use of the materials, and at the end, when the structure is no longer accommodate to the use of the building, or that structure can be completely disassembled and recycled, and also can become another completely thing without destroying the raw materials. Just adapt the repetitive parts and convert in a different thing. Yeah, this video shows how the deformation is. So during these years, we've been working to create different type of volumetric, and the idea is always bringing to a scale that is that has a space that we can use inside the structure. So this one specifically is the geodesic dome that we have been developing for years to bring a solution that can be used for different purposes. This is one of the prototypes that we built here in Canada. You remember, probably you guys remember this space. The work that we did in Autodesk, it was not just develop a prototype, but working in close with the some of the details inside the structure, and also make it more ready for fabrication, for mass production. So this is an example of how the structure works. So let me see. Yeah, it's working. So the structure initially is completely closed. Then, with not too many people, the structure is able to open and stand itself. And then the position of the structure can be changed and transformed back to the original location, the original position. Sorry, and that's the main goal for the parametric work that we are doing here. This is kind of the project that we recently finished here in Canada. As you guys know in the video, we have the structure completely closed. We bring the structure in this position to the location that will be located at the end. Then we open the structure. That is pretty simple. So like these pictures have like probably 20 minutes different, like you saw in the previous videos. It's pretty simple, and the structure is completely lightweight and can cover a very good area compared with the amount of material we use and how long time it took to make everything on that shape. And this is the final result of that one. So initially we just place the cover and we put the structure and we just made the cover. We made some custom additions to that design, but at the end, one of the uses that we can create for this kind of structure is the greenhouse. That is an habitable pop-up structure for domestic size that can help people to provide food security and organic alternatives for growing food at home. That's a good thing. And internally, the frame still looking as good as the customer use it for some kind of custom additions. That is, we like this kind of things, that the structure is available to hold those small things that the customers can use it and make it more familiar with the product. And this is one of the areas that we're working in Autodesk. As if I go back before, you see this point, or the connections between the straight bars. It was a point that we haven't developed very well, but using the time in the Autodesk residency last year, we developed a very good advanced hub that use generative design to give us a better understanding on how the forces of the straight bars are moving with the piece, with the hub, and we create this element that is helping us to have a better, more robust product. The next one, or the latest development that we are doing, is the vertex. That is basically an arch that can join between them and create a structure. So it's the same thing, habitable structure that can enclose or can become a shelf. And we are using for different purposes as well, depending on how we find a good use for these ones. But it's exactly the same concept. So at the end, you can just fold the whole structure and everything's come back to a compact size, and you can move it and put it in another place, or just put it in storage. Or at the end, if you don't like this anymore, you just disassemble everything, and exactly with the same material, with the same pieces, without wasting any material, we can build a dome or another completely different thing. That's one of the core values in our design. And as a conclusion, I just want to bring this idea that it's been around between us and as designers, that most of the stuff that we are doing in parametric design, it's or in Dynamo or Grasshopper, whatever software you want to use for that, it's kind of, sometimes it's just staying on the design. It's just helping the design to get something that it's very much, it's very repetitive, or can help you to create something that is more difficult to create manually, rather than create formulas and produce things that can use the computer power to calculate dimensions and areas and everything. But some of the stuff that we do usually gonna get built. That's basically the idea. And when we build things, typically the 70 or 90% of the discard, all of this material that I put here in this image get get to the waste or get discarded, and there's no a second use, or there's no more uh, um, another life that could be possible for those ones. So I just listed out some of the ideas that we work in our designs. That it is modular, it is pre-assembled, it is parametric, it is sustainable, it is lightweight. Uh, it's we have a very good chance that it could be recyclable, transportable, and at the end we can offer to the clients a very high return on investment, because the structure can be used many times, or the structure that the client pay for, it's not just one time in a life. It can be many times, like some of the wonderful products that we have. So yeah, that's all that I have to say for now. Thank you so much for inviting me.